Hi students, in this module I'll discuss some important question as per exam point of view. Since I have done coordinate geometry at last, so let me discuss the questions which comes in section D. Fine. In section D you will get all the questions from coordinate geometry only. Coordinate geometry. Fine. You can look at the question paper that in every year the repeated question will be, one question will be on distance formula. So let me revise once again. Distance formula, you have to remember the formula. It is given by, suppose two coordinate points x1, y1 and x2, y2 is given. Then distance formula will be x2 minus x1 whole square plus y2 minus y1 whole square. You can use this formula, or else I can write the same as x1 minus x2 whole square plus y1 minus y2 whole square. Among these two you can use any one of this formula. Now every year the repeating question is that based on the distance formula. In the question it was not directly mentioned that you have to use distance formula. Just by reading at the question you should know that we have to use distance formula. Like, look at the question. Show that the points 2, minus 2, 8, 4, 5, 7 and minus 1, 1 are vertices of a rectangle. What actually they have asked is the coordinate points, 4 coordinate points is given to us. We have to prove that they forms the vertices of a rectangle. So whereas in the next year the same concept question is repeated. See, 4 coordinate points is given, so we have to prove that those coordinate points forms a vertices of a rhombus. You can go through all the question papers. The repeated question is we have to prove the vertices of some of the geometrical figures. It depends on the questions asked. Fine. Before starting with the concept, let me revise once again. Have a look at the diagram, parallelogram. We say this since you are familiar with this, as we discussed the same while doing the vector algebra also. In parallelogram, as per the property of a parallelogram, what it says, in parallelogram opposite sides should be equal. Here opposite side for a side AB is DC, whereas opposite side for BC is AD. So in parallelogram, if they ask you to prove the given vertices or vertices of a parallelogram, you have to prove that AB should be equal to DC or CD, one and the same, and AD will be equal to BC. That is what the opposite sides are equal. So AB should be equal to CD and BC should be equal to AD. At the same time, so many of you made a mistake in the preparatory exam that you have proved only that opposite sides are equal, but the mandatory thing is that you have to show that diagonals are not equal. Remember, in a parallelogram you have to prove diagonals are not equal. So when they ask you to prove the given vertices forms parallelogram, you need to prove opposite sides are equal and diagonals are not equal. Coming to the rhombus. So if they ask you to prove the given vertices are rhombus, you have to prove that all the sides of a vertices are equal. The length of the sides are equal. That is, length of AB will be equal to length of BC and that will be equal to length of CD, and again it is equal to DA. At the same time, in the rhombus also diagonals are not equal. The difference is that in the parallelogram opposite sides are equal and diagonals are not equal, whereas in rhombus all the sides are equal but diagonals are not equal. Fine. And you have to remember this formula in some exams. I'm sorry, I don't remember the year exactly, but they asked you to find the area as well. In such a cases, remember, area of a rhombus is given by half into product of its diagonal. Here AC and BD is called as diagonal. So find the length of AC and length of BD using the distance formula as I said now, and substitute in this formula, you will get area. Fine. Now square. When they asked you to prove it is the vertices of a square, make sure that all the length of all the sides should be equal. That is, AB should be equal to BC and that should be equal to CD and that should be equal to AD. And moreover, in square diagonals are also equal. Remember, only in square and rectangle diagonals will be equal. Fine. Diagonals in the sense these lines. So in square and rectangle, only in square and rectangle diagonals are equal, whereas in parallelogram and rhombus diagonals are not equal. In parallelogram opposite sides are equal, in rhombus all the sides are equal, in square also all the sides are equal but diagonals are also equal, whereas in rhombus diagonals are not equal. And in rectangle opposite sides should be equal, in the sense AB to the side AB, DC is the opposite side. To the side AD, BC is the opposite side. So opposite sides are equal. Here the diagonal is AC and BD. So that should be equal. Fine. Difference between parallelogram and rectangle is that in both the cases, length of opposite sides should be equal, but in parallelogram diagonals are not equal. In parallelogram diagonals are not equal, but in rectangle diagonal should be equal. And remember formula to find area of a rectangle is A is equal to AB into AD. And rest of the things I think you are familiar with that, like equilateral triangle. Given a vertices, when they asked you to prove it is a equilateral triangle, in such case you have to prove length of all the sides should be equal. Fine. Whereas isosceles triangle is given, in such case you have to prove only two sides will be equal. Similarly, in case of right angle triangle, you have to verify the Pythagoras theorem. Fine. This is all the revision. That is, this concept should be now. This concept should be in your mind in order to solve the problem. Now let me explain one of the example so that you will understand the concept very well. Let me solve your question paper problem. See the question, what it is given in section D. Second question, show that the points is given 2, -2, 8, 4, 5, 7, -1, 1 are vertices of a rectangle. 4 points is given to us. Let me take these points as A, B, C, D. So I'll draw a rough figure rectangle, right? A, B, C, D. Coordinates of A is given to us, it is 2, -2. Coordinate of B is 8, 4. Coordinate of C is 5, 7. Coordinate of D is -1, 1. Right? This is what the question is. Now, just now I have told you that what is the property of rectangle says. Look at here. In case of rectangle, we have to prove that I have written here. To prove that AB is equal to DC, in the sense opposite side. For side AB, opposite side is DC. So this side should be equal to this side. And what else? For the side AD, opposite side is BC. So opposite side should be equal, and moreover diagonals should be equal. This is what we have to prove. Now, see here, rectangle I have to prove. First let me write our aim. To prove, what we have to prove? Opposite sides are equal. What is the opposite side for AB? For side AB, opposite side is DC. So I have to prove AB is equal to DC. Next, what is the opposite side for AD? For opposite side for AD is BC. So sides is finished. Now remember, I have to prove diagonals. In rectangle, diagonals are also equal, in the sense I have to prove AC is equal to BD. So if these vertices satisfies this condition, I can say these vertices forms a vertices of a rectangle. If this points does not satisfy the given condition, I can clearly write the given points does not form a vertices of a rectangle. Now let me check. First let me find the length of AB. When I said AB, it is distance between the point A to B, or I can say it is distance from the point A to B, right? Now first let me find the length of AB. Fine. What is the distance formula? D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Since I have taken the side AB, so what are the coordinate point I required? First point is A. So A coordinates is 2, -2. Next point is B. Write down the B coordinates, what it is? 8, 4. Now let me take this point as x1 y1, this point as x2 y2. Remember, the standard form is x comma y. General form is x comma y. First point has to be taken as x, second point has to be taken as y. Don't interchange this position. Now let me substitute here. D is equal to square root of x2 is 8 minus x1 is 2 whole square plus y2 is 4 minus y1 is minus, since you have minus here, minus of minus is plus 2 whole square. Now 8 minus 2 is 6 whole square plus 4 plus 2 is 6 whole square. 6 square is 36 plus 6 square is 36. Now 36 plus 36, you just add it. So when you're going to add these two, you'll get AB as square root of 72. Now I have to find the length of DC. Use the same concept. Let me find the value of DC. What are the coordinates required? First, let me note down the coordinates of D as minus 1, 1 and coordinate of C is 5, 7. Fine. X1, Y1, X2, Y2. I'll substitute in the same formula. No need to write again. So what is the length of DC will become x2 minus x1 whole square. So 5 minus of minus plus 1 whole square plus y2 is 7 minus y1 is 1 whole square. You will get 5 plus 1 6 square plus 7 minus 1 6 square is again 36 plus 36. What you're going to get is root 72. So DC is equal to square root of 72. So you can note that first condition is satisfied. What is the first condition says? Opposite side for AB is DC. So those two sides should be equal. So what I'm going to get is AB will be equal to DC. First condition is satisfied. Next, let me find the length of AD. Use the same procedure. AD. Find coordinate of A is 2, minus 2. Coordinate of D is minus 1, 1. So x1, y1. X2, Y2. Use the same formula. You will get D is equal to x2 minus x1 whole square plus y2 minus y1 whole square. What you are going to get is minus 3 whole square plus 2 plus 1, 3 square. Minus 3 whole square is 9 plus 3 square is 9. What you are going to get is 18. Length of AD is square root of 18. Now what we have to find is length of BC. Right? B coordinate is 8, 4. C coordinate is 5, 7. Nothing. You just go through the condition given and write down the coordinates of the vertices of the vertex point and substitute in the same distance formula. So I'm going to find BC as square root of, let me take this as x1, y1, x2, y2. x2 minus x1 whole square, here it is, plus y2 is 7 minus y1 is 4 whole square. So 8 minus 5 is minus 3 square plus 7 minus 4 is plus 3 square. Again it is 9 plus 9. It is square root of 18. That is length of BC is square root of 18. So again the second condition AD is equal to BC is satisfied. I have got AD is equal to BC. So generally what you're going to do is you're going to stop here itself, but you're not going to get full mark. You have to solve the length of a diagonal. You have to prove that length of a diagonal is also equal. So now use the same formula to find the length of a diagonal. Now what is the diagonal we have to find is AC. Third condition I'm going to check now. AC. Fine. A coordinate is 2, minus 2. C coordinate is 5, 7. So AC, again I'm going to use the same distance formula. Square root of x1, y1, x2, y2. x2 minus x1 whole square plus y2 is 7 minus of minus plus y2 whole square, which is equal to 5 minus 2 is 3 square plus 7 plus 2 is 9 square. You are going to get 9 plus 81 is 90. So length of AC is 90. Fine. Next what we have to find is length of BD. Length of BD. B coordinate is 8, 4. D coordinate is minus 1, 1. See here it is. D coordinate is minus 1, 1. B coordinate is 8, 4. So BD will be equal to, let me take this as x1, y1, x2, y2. So x2 minus x1 whole square plus y2 minus y1 whole square. Minus 1 minus 8 is minus 9 whole square plus minus 3 whole square. Minus whole square, negative whole square will become positive. So 9 square is 81 plus 3 square is 9. So again it is 90. What you're going to get is BD is also square root of 90. So I can say AC is equal to BD. So from the diagram it is clear AC and BD are diagonals. So what we have to prove is all the three conditions should be true. Look at here. I have proved AB is equal to DC. So that first condition satisfied. Next I have proved AD is equal to BC. So that second condition is satisfied. Next I have proved diagonals, that is AC is equal to BD. Third condition is satisfied. Since all the three conditions is satisfied, I can say conclusion also. There is one mark for that. You have to write the conclusion. That is, therefore, the given vertices forms a vertices of a rectangle. Hope it is clear for you. So whatever the question will be, if they ask you to prove vertices of some certain geometrical figure, you must and should use distance formula. That is understood. Okay. Now let me explain one more example. Look at the question here. Prove that 5, 1, 4, minus 2 and 3, 0 forms right angle triangle. Question is right angle triangle. So as per the condition that I have said earlier, when do we say given vertices form a right angle triangle? Only when it satisfies Pythagoras theorem, right? This is what the Pythagoras theorem, that is hypotenuse square will be equal to sum of the squares of other two sides. Fine. Now three vertices is given to us. First let me name that. 5, 1, B as 4, minus 2 and C as 3, 0. Fine. Now what we have to prove is it forms right angle triangle. But initially we don't know. Suppose, let's see here, I'm going to draw something like this. Fine. Initially we don't know which is hypotenuse side. Suppose if I'm going to take this vertices as B, then AC will become hypotenuse, right? Suppose if I'm going to take this vertices as A, then BC will become hypotenuse. So I cannot directly write Pythagoras theorem and verify something else. So I cannot write this. First I have to find length of, consider any of the sides, like first find AB, next find length of BC, next find length of CA. So since it is a triangle, it should have three sides. So blindly I have taken three sides like AB, BC, CA. Still I don't know whether it satisfies Pythagoras theorem or not. I have to verify whether it satisfies or not. If it satisfies, then only what we say, it is a right angle triangle. If not, it is not a right angle triangle. That is what we know. Now let me find length of AB. We have to find length of all the three sides. First let me find length of AB. I need vertices of A as 5, 1 and vertices of B, it is given 4, minus 2. So let me take this as x1, y1, x2, y2. Again the distance formula. When I said AB, it is distance between A and B. So clearly it is x2 minus x1 whole square plus y2 minus y1 whole square. Fine. Just the substitution part. x2 is 4 minus x1 is 5 whole square plus y2 is minus 2 minus y1 is 1 whole square. 4 minus 5 is minus 1 whole square plus minus 2 minus 1 is minus 3 whole square. So what you're going to get is minus 1 whole square is 1, 3 square is 9. So it is square root of 10. That is length of AB is square root of 10. Fine. Next BC. Let me find length of BC. I'll do here. BC. B coordinate is 4 minus 2, C coordinate is 3, 0. Again I will use in distance formula. So you will get, this is x1, y1, x2, y2. So x2 minus x1 whole square plus y2 minus of minus plus y1 whole square. So 3 minus 4 is minus 1 whole square plus 2 square. You will get 1 plus 2 2 is a 4. Fine, 4 plus 1 is square root of 5. So length of BC is square root of 5. Now let me find length of CA. So C coordinate is 3, 0. A coordinate is 5, 1. So this is x1, y1. This is x2, y2. Again the distance formula gives x2 minus x1 whole square plus y2 minus y1 whole square. 5 minus 3 is 2 square plus 1 minus 0 is 1 square. 2 square is 4 plus 1 square is 1. Again what you're going to get is root 5. So length of CA is square root of 5. Length of BC is square root of 5. AB is square root of 10. Now Pythagoras theorem. In Pythagoras theorem, as per the statement, AB square is equal to what is that? BC square plus CA square. So in every term, for every side, you have a square. So first what you're going to do is first find the squares, length of the squares. That is AB whole square is square root of 10 whole square. So square and square root get cancelled. You will get 10. Fine. That is, I can write AB whole square is equal to 10. Fine. Now BC whole square is square root of 5 whole square. Square and square root get cancelled. You will get BC square is 5. Fine. Similarly, CA whole square is equal to square root of 5 whole square. Square root get cancelled. CA whole square is 5. Now look at all these three measurements. Which is the highest one is 10. So that will become hypotenuse. So I can write AB square as BC square plus CA square. Right? See, AB square is 10. I can write 10 as BC square is 5 plus CA square is 5. Since it is satisfying Pythagoras theorem, right? 5 plus 5 is 10. 10 is equal to 10. So it satisfies Pythagoras theorem. So what is the conclusion that we can say? Therefore, the given vertices form vertices of right angle triangle. The only thing is, first you have to write down the vertices given and make sure what we have to prove. The main thing is we are going to make use of distance formula in this case also. I hope it is clear for you. Since this is revision class, so I am not going to solve much more examples, and here you have assignment revision questions, and you have to solve these questions in an assignment book, and you have to submit the same when coming to the college. Then only you will get a hall ticket, otherwise you are not going to get hall ticket. So please make sure you are going to solve all these problems in the assignment book. Thank you.